Hello everyone, welcome to this new session on switching theory and logic design. Myself Dr. Sohail Rana, and today we are going to begin a new chapter called binary codes. So this is our part 1 video. In this we will discuss about the classification of binary codes and other topics. So let us begin with our session. So actually numeric and alphanumeric codes we require for any conversation between the human and machine. Machine is a computer system where we have to use our knowledge and create some programs and codes which should be able to convert it into the language of machine. The language of machine is binary. So binary codes can be classified as numeric codes, say numeric codes, and alphanumeric codes. Broadly we can say we can classify them as numeric codes and alphanumeric codes. Numeric codes are which they represent the numeric information. That means only numbers. That is, say, for binary it may be 0 and 1. Only numbers they represent. And suppose other examples are like gray code or XS3 code. These are numeric codes that we will study in this chapter. Numeric codes used to represent the decimal digits are called binary coded decimal code. So that is something called BCD we have to study, or 8421, 2421, 5211 are BCD codes. There are different types. And alphanumerical codes which represents both letters and numbers. Right, alphanumerical codes, they can represent the information related to numbers as well as letters. And decimal numbers and sequence, zeros, ones. And the example of say alphanumeric number is say we can use the ASCII codes. In this we have numbers, characters, special characters, and all of them are included. So for if when you hit A or B or dollar or exclamatory mark or question tag or 1, 2, 3 on the keyboard of a computer, then each of them, all these buttons have some fixed ASCII code in the background. So these are like alphanumeric numbers. Now a BCD code is one in which the digits of decimal numbers are encoded one at a time into the groups of 4 binary digits. These codes can combine the features of decimal and binary numbers. There are a large number of BCD codes. So in order to represent say decimal numbers from 0 to 9, it is necessary to use a sequence of at least 4 binary digits. Such a sequence of binary digits which represents a decimal digit is called a code word. We call it as a code word. Right. So what is code word? A sequence of binary digits which represent the digital digit. All BCD codes have at least 6 unassigned code words. Anyway, we will see it in the BCD example. Then say we will discuss what are the weighted and non-weighted codes. Say weighted and non-weighted codes. Right. Now BCD codes, what is long form of BCD? That is binary coded decimal. All of us should remember this. BCD is, the long form of BCD is binary coded decimal, right? So this is binary coded decimal. We have to remember this. So for the BCD codes may be weighted codes or non-weighted codes. So this can be say weighted or non-weighted codes. The weighted codes are those which obey the position weighting principle. So they follow some principle. Which principle? Position weighing principle. Now each position of the number represents a specific weight. Okay. For each group of 4 bits, the sum of the weights of those positions where the binary digit is 1 is equal to the decimal digit which the group represents. So say in the types of BCD 8421 or 2421 or 84-2-1 are weighted codes. And non-weighted codes are the codes which are not assigned with any weight to each digit position. That is, each digit position within the number is not assigned fixed value. Excess 3 code and gray code are non-weighted codes. So there are further 2 types of different codes. Say excess 3, it is written as XS3, and the gray codes. So these two, they don't follow the fixed position principle. There are several other weighted codes also, right? Now further, there are 2 types of weighted codes. So we'll see about them. So there are 2 types. One is positively weighted and negatively weighted codes. Now like this we can classify them. Now the weighted codes may be either positively weighted or negatively weighted codes. Positively weighted codes are those in which all the weights assigned to the binary digit are positive. All the weights will be positive. There are only 17 positively weighted codes. In every positively weighted code, the first weight must be 1. The first weight must be 1. The second weight must be either 1 or 2. Second one should be either 1 or 2. And the sum of all the weights must be equal to or greater than, sum of all should be equal to or greater than 9. Like the codes 8421, 2421, 5211, these are some of the positively weighted codes available. Now negatively weighted codes are those in which some of the weights assigned to the binary digits are negative. The codes like 642-3 or 631-1, these are some of the negatively weighted codes. So you can see these are some different weighted and non-weighted codes. So here is the table. In this we can see the list. Here we have decimal digit. This is decimal digit, say 0 to 9. Decimal numbers from say 0 to 9. Now we have different BCD codes. These are all different BCD codes. This one is 8421. 8, 4, then 2, 1. 1 means say 1 gap, 0 1 0 1 0 1 0 1 0 1. At this position gap is 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros. Then here is gap is 4, 1 2 3 4 zeros, then 1 2 3 4 ones. After that again same. Here we have gap of 8 zeros followed by ones. Here 3 3 2 1 code. That means what? Say here we have, this is one pattern of 1. Here we do the shifting, right? So these are few. For this we can easily remember the codes, right? Others we will see when the example comes. So these are about the BCD codes. Now there is another thing what we should discuss is about error detecting and error correcting codes. There will be different error correcting and error detecting codes. That also we will discuss. Error detecting and error correcting codes. So binary codes may also be error detecting codes or error correcting codes. Codes which allow only error detection are called as error detecting codes. Like say we'll have shift counter code or 2 out of 5 codes are error detecting codes. Codes which allow error detection as well as error corrections are called as error correcting codes. The example is Hamming code. Hamming code is error correcting code. So this is example of error detection, and error correcting example is say Hamming code. Then there will be some sequential codes. Then next type we have to remember, next terminology is sequential codes. So the sequential code is one in which each succeeding code word is one binary number greater than the previous code word. Such a code facilitates mathematical manipulation of data. The 8421 or the XS3 code, these are sequential. The codes 5211, 2421 and 642-3 are not sequential. Then there will be self-complementing codes also. Say self-complementing codes. Self-complementing code is the one if the code word of the 9th complement, in first chapter we have seen the 9th complement of say capital N, that is 9n, can be obtained from the code word of n by interchanging all the zeros and ones. Therefore, in a self-complementing code, the code for 9 is the complement of the code for 0. The code for 8 is the complement of the code 1 and so on. So the 8421 and 5421 codes are non-self-complementing, but XS3 is self-complementing code. Self-complementing codes have an advantage that their logical complement is the same as the arithmetic complement. Right? Arithmetic complement means what? Say 0s 1, 1 2, 0. Then there are some cyclic codes, and there are reflective codes and straight binary codes. So there are different type of codes. So here is, say we will discuss some 8421 are also called as natural BCD code. Say the natural BCD codes, or the 8421 8421 BCD code. Here we can see a table, the classification of code. What we are saying, there may be cyclic codes, or there may be reflective codes, or straight binary code. So codes we can classify, say broadly, numeric or alphanumeric. Then numeric may be weighted, non-weighted, self-complementing, sequential, error detecting and correcting, reflective and cyclic. Reflective means is a binary code in which the n least significant bits of the code word 2 to the power n through 2 to the power n plus 1 minus 1 are the mirror images of those for 0 through 2 to the power n minus 1. Now the gray code is reflective, right? And cyclic codes are those in which each successive code word differs from the preceding one in only one bit position. That is also gray code. When we will discuss about these gray codes and all, then we will understand the meaning of this. Then again, non-weighted codes are XS3. XS3 is non-weighted and sequential. And again, weighted codes may binary and BCD. In BCD we have the natural 8421, then 2421, 3321, 4221, right? So these are different codes. So XS3, these are they are self-complementing also, sequential also, non-weighted also. And when we talk of alphanumeric, where we can use the numbers as well as the alphabet. So ASCII is there, EBC, DIC is there, Hollerith is there. These are different types. So there are so many different types for this. Now 8421 BCD code is so widely used. Out of this, the most widely used is 8421. This is called as the natural BCD code, or simply BCD code. When BCD code is simply given and no other notation is added, then it is considered as the natural 8421 BCD code. We have to remember this. In this code, each decimal digit 0 through 9 is coded by 4-bit binary number. It is also called natural binary code because 8421 weights attached to it. It is weighted code and also sequential. So what we have to remember about 8421, it is weighted and sequential, right? Okay. Therefore it is useful for mathematical operations. The main advantage of this code is its easy of conversion to and from decimal, and we can also easily remember this. So how pattern goes, say 0 0 0 0, first one, say 1 means 1 1 gap, 0 1 0 1 0 1 0 1. Second means gap of 2 zeros, 2 ones, then 2 zeros, 2 ones. The next gap of 4, say 4 zeros, then 4 ones, and last gap of 8. First 8 zeros and then 8 ones, so on. So it is less, but it is less efficient than the pure binary in the sense that it requires more bits. For example, the decimal number 14 can be represented as 1110 in pure binary, but as in 8421 we represent it as 0001 0100. So that is a kind of drawback, we can say. Another disadvantage of the BCD code is that arithmetic operations are more complex than they are in pure binary. There are 6 illegal combinations. So we will list out the 6 illegal combinations in BCD. Say number 1, 1010, then number 2, 1011, number 3, 1100, then 11, 0 1 1 1 1 0. Like that there are 6 illegal combinations we have to remember. That is one disadvantage. That means they are not part of 8421 code. Okay. Then next, another disadvantage of 8421 code is that the rules of binary addition and subtraction do not apply to the entire 8421 number, but only to the individual 4-bit groups. That is another disadvantage. Okay, so these are some disadvantages and advantages for BCD. Now this is about some introduction to BCD codes and some codes system. We have analyzed the types, and there are different methods what we can use here. Now by using that, we have to perform various operations like BCD addition, BCD subtraction, then BCD subtraction using 9th complement or 10th complement. We have to see different codes. Apart from BCD, we have to study XS3 code, Gray codes, and how we use them in the examples. So these all examples and their how to solve them we will begin in the next session. So it was introduction to this chapter, and in next session we will solve the examples, but for that we require all these basics to be understand more properly. What are the codes, what are the types, and what all we are doing. We are to just manipulate the data which we require. So see you in the next session. Thank you. Have a good day.